Hello everybody, Chris here, and in this video I'm going to be showing you guys how to set up Grid Builder version 3.1.1. So this is my Godot 4 plugin for placing objects onto a tile map grid during gameplay by evaluating certain rules that you set for both the building system or individual placeable objects in order to evaluate if placement should be allowed. So that can be things like collision or checking if there's enough resources in the player's inventory container to allow placement and then spend those resources. So I've gone ahead and set up a really basic 2D level. So this is using Limezu's Modern Interior Packs on itch.io if you're curious. So you can check that out. And so we're going to be able to take this level and turn it into where we can actually place objects during gameplay. So we have this level scene. I could embed systems into it, but I would rather separate the background logic from the level itself. So I'm going to create a new scene over here. And this new scene is actually going to have just a basic node as its root. So we're going to call this something like gameplay, or you could call it main. So the main point of this is to have background systems that are going to carry over from level to level, loaded up in the main gameplay node. And then you can switch out the levels if you want as your character switches scenes. So inside of here, I'm going to add another child node just for organization. And I'm going to call this systems. And then right here, we can also put in the level that we want to load first. So I'm going to search level in the project, and I'm just going to pull in that .tscn packed scene that you saw a moment ago. So that actually brings in the 2D level here. And the reason you would use normal nodes here is that these nodes and everything under them is separate from the actual 2D game world. So if it's a node 2D, it's part of the world. If it's not, then it's just background logic. Okay. So here's where we'll put the building system in the grid targeter system. Okay, so to add the system in, of course, we need to actually install the plugin first. So I'm going to create a new folder in the resources down here in the bottom left file system. Right click, new folder, and then I'm going to give it the name add-ons. So add-ons is the standard folder you would install all Godot plugins into. So inside of there, we're going to want the grid builder plugin. So I'm going to right click here and do open in file manager. And then I'm just going to drag the assets into here, the grid builder folder. So if I go to where I have the zip files for my plugins, I'm going to double click here and I'm going to grab grid building and I'm just going to copy that straight into here. So if you double click into here, you can make sure it has these folders and it should have a plugin.cfg file so that we can enable the plugin. And you can check out the README if you want more advice on how to set things up. But for now, as long as we make sure that grid building is installed, we can enable the plugin. So we're going to want to go up to project settings and go over to the plugins tab and check enable. So when we do that, it should add all of the class names to objects that we can create inside of our scene. So if we right click here and go to add child node, you should see some new class names pop up in the script associated with them. So we want to add a building system to our systems hierarchy. So double click there, that's the main system for the plugin. But to go along with that, we're also going to need a grid targeting system. So we'll create that. So the grid targeting system, if we select that and we expand dependencies, needs a positioner and a tile map. So for the tile map, if you already have the tile map loaded inside of the scene you're loading, then you can just assign it in the inspector, which is easy and convenient. But if you load the level up later on, such as during gameplay, a new level gets loaded into this hierarchy, then you'll need to manually set the tile map during gameplay by just assigning the property tile map equals the new tile map from the loaded level, or you can call the setup function in both grid targeting system and building system. But for right now, for easy testing purposes, let's right click on level modern interiors, and I'm going to do editable children, and that exposes all of these other nodes under here. So we can just assign the tile map to the grid targeting system. And the building system also depends on having the tile map assigned. So knowing the tile map allows you to snap to the grid, and it also allows you to know what you're testing against with all of the rules. Okay, the next thing we need is a positioner. So the grid targeting system is going to move that positioner around the screen, and it's going to snap to each of these tile spaces. But in order to move it, we need a reference to it. So this only needs to be a node 2D. But if you want to have an out-of-the-box animated graphic for it, what we can do is right-click on gameplay. I'm going to add a child node, and this will be a node 2D. I'll call this one world. Now I'm going to nest the level under here. And now anything that's outside of the level, but is still a 2D node component, we can put under world. So to have the animated sprite targeter, I'm just going to search the project here for targeter. So we have grid targeter.tscn. I can just drag that right here. And we should see this graphic pop up here. It has a little animation that will play during gameplay. So we can go to grid targeting system and assign that as the positioner. And then the building system also needs to reference the positioner. So what the building system does with the positioner is when you choose a preview scene for what you're going to be placing into the scene, it's going to snap that position to the positioner. So wherever you point the cursor is going to be snapped to the grid. And then the placeable object is also going to snap to that same position. So we also need a placed objects parent. So this is just going to be where you decide to place your objects into the game world. So if I expand the level here, I made a root node here called objects. You can see all these other objects inside of the scene are attached to that. So that would be a good candidate to use for the placed objects parent. So if I assign that, this is just going to mean new objects that are created during gameplay are going to be nested under here. So any 2D node works for that. And then lastly, we have the placer, which is the node in control of the building system, the object considered to be placing objects inside of the game scene. And also where it would look for an inventory if you happen to be using the spin materials rules. So in this case, we don't really have a player character, but I did create a camera with a simple move script, which looks like this, in case you're wondering. So just WASD to move, custom build actions, and assigning that times the delta and the input to get our change in position. So super simple. And we will just use this camera 2D node as the placer. So I'll assign camera 2D. You can see it can be any node. It doesn't even have to be a node 2D. And that's pretty much it for our external dependencies. Now on the build system as well, we are going to need to have a couple resources set up. So building signal bus is where signals get emitted. So if you want to respond to events happening on the build system, like an object being placed or a rule validation failing or succeeding. So this is the resource object you would connect for that. So if I just click here, new building signal bus, that creates it. And now if I want to reference it in any other script, we should save it to the project. So I'm going to right click here, save it. And let's just find a new folder for, we'll say signal bus. And I will put it into here as main building signal bus. So the building system is going to emit signals through this building signal bus, and any other script can respond to it just by connecting to the same signal bus. So this is helpful because it allows you to receive data from the building system without directly referencing the building system. So if you have different scenes being created at runtime and you can't just assign the building system in the inspector, you can always assign a resource from your project because those are always there in the file system. Okay, next the placement validator. This manages the base rules and validating all of the rules against the preview instance and using rule tile indicators to do so. So let's create a new placement validator. Inside of here, the main thing you need to be concerned with is adding base rules. So if you have a rule that you want to apply to everything in your game by default, any placeable object, then you want to add it here. So we'll come back to that in a minute, setting up the base rules. And then a rule check indicator template. We can just quick load that from the project real quick by putting in here rule check indicator. There's two versions here, the rule check indicator and the rule check indicator minimal. The difference really here is just that they're using different textures. The one on top puts a little B in every tile space, and then the minimal is just a background texture. Otherwise, they're the same. So I'll just use the main one instead of the minimal. And you can click here and open the scene. So this is just a packed scene. You can see it here. Inside of this scene, you have valid settings and invalid settings. So these are the textures that are going to display when the indicator validates successfully or when it fails. So when you're placing objects into the scene, a whole bunch of rule check indicators are going to be created as long as you're using collision rules or tile check rules. And that means that each of these spaces are going to evaluate individually. And you can see where the problem is if there's a conflict for things like collision. And if you happen to not be using a 16 by 16 tile set, then you would want to come in here to the shape size and bump this up to 32 pixels or something for 32 by 32 pixel. I just have it slightly under, just so that these tile spaces never conflict with each other for any reason. Okay, so back out in our gameplay scene. We have the indicator set up. We have the building signal bus. There's some other miscellaneous settings here, including if you want to enable a drag multi-build, where you press and hold the build button down, and as you move the mouse cursor, it'll keep attempting to build new objects if there is space for it. And then setting up the action names for triggering things in the build system, like rotating to the right or actually building. So you can see here that UI accept is the default build name, and UI cancel is the default exit build mode, which just cancels the building placement. So this is escape and this is enter. But these UI actions, which are default in every project, may be used by other things in your UI. So it's a good idea to change these out with custom actions that are only used by the building system. So we could go ahead and do that now real quickly. Let's go to project settings, import map. I'm going to add a new action here. So let's say exit build, enter. So for the exit build action, I'll just set it to something like T. And then we just put the string name into this field, exit build. And that's how you assign the action. So now quitting build mode is T on the keyboard. And we can do something similar for the build action name. So this is when you actually place an object into the game. Let's go project settings. I'll say new action build. And I'll assign this to left mouse button click. And then we'll hit close. So build action. Okay. Now we haven't saved this gameplay scene. Now is probably a good time to do it. So I'm going to hit Control S, go to the root, and I'll just save gameplay.tscn. You could also call it something like main.tscn, whatever makes more sense to you, but it's basically where you load up the game. So I'll save here. So now let's actually set up a placeable resource so that we can use that with the building system in order to try building into the game scene. So inside of the project, wherever you want to put your placeable resources, that could just be in clothing store here, or you can have a completely separate folder for where you put them. But I'll just try to keep matching things together. So for the placeable resources, I want those to place these .tscn files. So clothing mannequins, clothing rack, gaudy mirror, wall mirror, that kind of stuff. If you want to place them into the game, you need a placeable resource file for each of them. So I'll create a new resource. And if we search placeable, we should see this as long as the plugin is enabled. So let's do clothing mannequins underscore placeable.tres. Save. Okay, and now we have a placeable resource to go along with this actual gameplay scene. So in the placeable resource, I'm going to give it a display name, clothing mannequins. For the icon, how I want it to be displayed in UI, what I can just do is click here, grab this resource, I'm going to copy it for the texture, go over to placeable, and I'm going to paste it in for the icon. And there we go. We're using the same sprite as the UI icon. But for an actual game, you might want to use a smaller texture or something that's scaled down so that it's smaller in the UI. So for the packed scene, that's just going to be this TSCN file. So I'm going to drag that in here. And there. So when you're doing a building preview, it's going to create a copy of this that has no scripts running unless you specifically designate special nodes to keep their scripts. And you would do that down here with preview excluded nodes. So if there's a script that does animation and you need that to stay there, you would add it as a node path down here. But for most cases, it's just going to remove all the scripts, and that should be fine. And then in the gameplay scene, any of the collision objects, like the static body 2D, which have collision shapes, if you're using tile check rules, it's going to grab those collision shapes and use that to generate indicators for each of the tile map tiles that these shapes hover over. And it'll do that if you match the shapes, or more specifically the collision objects, based on their layer. So we'll get to that in a second. But just kind of remember that by default, your collision objects are on layer 1. So you want to mask layer 1 if you want to grab these collision shapes to be used by the indicators. Okay, so then if you have any placement rules you need to assign to only one placeable, only this placeable, like a spend materials rule, because different objects are going to cost different amounts of resources to place into the game, so it makes sense to put it here. Then you can do that. Otherwise, the rules go on base rules. You can ignore all the base rules if you want to just have only these rules evaluate. There may be some outlier cases for that. But aside from that, that's basically the gist here. You can also toggle if a placeable is allowed to be rotated or flipped during build mode. Once again, if you want to do that, you have to set up the build action names in the building system in order to rotate or flip. Okay, so now we can work on the simple placement UI. So the build system, in order to go into building preview mode, has to have set building preview called on the building system. So one way you can do that is by setting up some UI that will select a placeable, take that placeable, call the method on the building system, and then the building system takes over in build mode. So to set up a simple template UI, let's right-click on the gameplay and go to Add Child Node, and we're going to start with a canvas layer. So when you add control nodes under canvas layer, the canvas layer renders basically in front of the camera. It doesn't move with the camera. It's separate from the 2D game world. And that's important because if you have a HUD or a heads-up display, you don't really want that to move around on the screen. You want the positions to remain static. So generally, adding your control nodes under a canvas layer is a good idea. So what we want here is going to be, I think I called it something like placement selection UI. So if you search placement selection UI.tscn, we can just drag this into here as a default UI that we can try using the build system with. Now, obviously, it's very rudimentary. It hasn't really been themed or anything. So this is mostly for testing purposes, really. But let's customize this. So external dependencies, we do want to assign a build system. So I'm going to assign the build system directly here. And then under settings, we might want to give this menu an option to open. So open actions, we can assign a new action here, and I'll call it open build. So in project settings input, let's add a open build action, and I'll set this to the B key. So by doing that, basically we can toggle this UI to open on just by hitting that button, open build, the B key. You can also check if you want it to show at the start, mostly useful for debugging purposes, just to make sure that it's positioned correctly. And the default positioning here is actually using custom anchor points. So if we look here, custom anchor points basically gives it a position on the screen, and it scales up and down with your UI size. So for placeables here, we want to assign the placeables that this menu is actually going to show so that we can select and place them with the build system. So I'm going to add that new placeable we created. So placeable, we have clothing mannequins placeable, just drag and drop that in. So this UI works by having tabs for different categories. So you can have like a tab for clothing, a tab for maybe walls and stuff, or a tab for office furniture, whatever. So in order to get those tabs to show up, you create category tags, which is just a resource with an icon and a display name. So let's create a new category tag here. I'll expand this array, click here. Now, new categorical tag. And then this will be clothing. For the icon, I'm actually just going to use the clothing mannequins placeable icon. So I'm going to right click here, copy it, and then let's click on the UI, go to that tag, and I'll just right click, paste it here. So cool, we're using this icon, which is pulled from a Atlas texture. Okay, and how these categorical tags work here is that anything that has this matching tag in the placeable, like right here where it has tags, is going to be grabbed and placed under this category. So if I right click here, I can save this to the project, and let's go upper folder and objects. I'll create a new folder, and I'll just call this categorical tags, and then we'll save this as clothing tag.tres. And now, just like with every other resource file, since it's saved into the project, we can just put it here in tags very easily. So let's go find that categorical tag, clothing tag, drop it into tags here. So you might notice that tags on the placeable is just made a generic resource. So if you're not using this UI, you don't actually have to use this specific class for tags. It can literally just be any resource. And to compare tags, you just check if that resource file is inside of tags. So I think that can be a pretty good and general way of labeling things. So if you had like a special move, a special attack, and maybe it was fire element, then you could give it the tag fire or something. And now you know that that attack is fire element, and you can plan your game accordingly. Okay, so that is pretty much the setup for our placeable there. We have the categorical tag, and we have the key to open the build menu. So let's go ahead and test this out. I'm going to hit play, and we will see if this works all right. So we haven't set a main scene, but we do want this gameplay scene to be the main scene, so I'll select current. Okay, and we have our scene, WASD on the camera, using that little move script I showed you, and we can hit B to open up our build menu. So we have the clothing mannequins here. This references the placeable that we want to place, and we have the tabs up here at the top. So I'm going to select clothing mannequins, and we'll see if that allows us to place into the game. Okay, so we do get the preview scene here. You can see that there's like a little bit of a ghosting effect. So that's colors that you can set up on the build system if you need to change that, either in how transparent it is or what color the preview shows. You'll notice this, there's no rule indicators yet because we're not using any tile check rules. And because there's no rules, basically we can just press and set this up anywhere we want. I can basically just press around the screen and have a bazillion of these objects. So what we need to do is set up some rules to actually constrain the build system. So in building system, we can finally go into placement validator now. And base rules, we want to, let's just start with 1. And I'm going to click here and do a collisions check rule. So on the collisions check rule, so you'll see that there's an apply to objects mask. Any tile check rule is going to have one of these. So in your placement scenes, if I go look at something like Godot mirror here, you'll see that these scenes are set up so the root object is actually a collision object 2D. A static body 2D is a collision object. An area 2D is as well, or a rigid body, a actual physics object that gets affected by things like gravity, is also a collision object 2D. So anything that's a collision object 2D needs a collision shape attached to it. That's these shapes here. And so the rule indicators are going to generate based off of this layer, the collision layer that's set up here for this object, and the shape underneath. And also that applies to any nested collision objects as well. So like you could have an area 2D inside of your Godot mirror that might just be a placement collision shape, but not actually meant to have in-game collisions. Okay, so now you know where the rule indicators are coming from. When we have apply to objects mask, if this matches the physics layers on the collision object, then it's going to grab the shapes and generate rule indicators for it. Now the collision mask, when it's actually validating the rule, it's going to check on these masks to see if each of the tile indicators have a collision on that area. So by default, a collisions check rule wants there to be no collisions, but you can toggle pass on collision on if you want there to be a actual collision in order for there to be building placement. So that might be if you have like a layer for buildables, something like there has to be a buildable tile under the placed area in order to place the object. So that would be more for like platformer games and that kind of thing. But for right now, we just turn off pass on collision and we can leave the defaults here. And let's hit play. Okay, so now I'm going to hit B to open the menu, clothing mannequins, and you can see we generate rule tile indicators for each of them. And if I hover over the wall, you can see that there's a collision against the wall, and it's not going to allow us to place the object into the game scene. Also, if I go above the wall, where there are no tiles at all, once again, we can place because there's no collisions there. So I can place into the hallway, which we want, but we wouldn't want to really be able to place outside of the scene entirely. That doesn't really make sense. If I left click on the walls, you can see that that's being blocked successfully. So how do you prevent your building system from allowing you to build where there's no tiles at all? There's another rule for that. Let's add an element, and we'll click here and do a within tile map bounds rule. So with this, we're going to apply to objects mask 1 again. So any object that is on layer 1 is going to be pulled in to generate the tile indicators. And we just want to make sure that there is actually tile data under the tile for each indicator. So if I hit play here, and let's hit B, clothing mannequins, and we try to place up here, you can see it's not allowing us to. These are not valid placement areas, but down here is. So we can still place in the hallway, but not outside of the scene. And those two rules are basically the core of placing in a top-down game, at least. But it would probably be nice if we had a little bit more feedback about what was actually going on internally in the system. Your player might want to know why something was allowed to place, or more importantly, why it wasn't allowed to be placed. So if we close this out, there's another default UI we can throw in here, which is the build log. So a build log TSCN, I'll just drag that up here. You can see that it's currently by default in the bottom right-hand corner, but we can go to layout and do anchor points and just adjust that over to the left if we want. In a future update, I might actually just default it to the bottom left-hand corner, but you can just customize this to be wherever you want. And if you want there to be a background for this UI, you can right-click here, go to Editable Children, and on the 9-patch rect, you can assign either a normal 9-patch rect, or you can make it simple just with a new gradient texture 1D. And then go to visibility, self-modulate, and lower the opacity up and down as much as you need the background to be. Okay, let's see. On the building log, we do need to assign the signal bus. So this is one of the objects which would actually get data when the build system fails or succeeds at doing the building placement. So let's load the building signal bus into here, the TRES file. And we have that there. So this build log doesn't actually need a direct connection to the building system at all. It just needs to have the same signal bus referenced. So if we want to show all of the messages, we might do show validation messages, Print successful reasons, if you want to know why it succeeded. By default, print failed reasons is on because that makes a lot of sense. And then on ready message, we could say, welcome to the game, building log is loaded, or something. So that'll just be the first message that gets displayed here. So let's hit play. And we're going to have the build log there in the bottom left. So let's place something into the scene. I'm going to do clothing mannequins, and let's go up here, left click, and you can see, oh, it didn't allow it to place. The rules failed. Why did it fail? Tried placing outside of valid map area. And you can customize each of those messages as well. And the build log is really just a default build log. You'd probably create your own custom one in the end. But let's go ahead and try having a successful placement. So we'll press here, and we can see all building placement validation checks passed, and we checked no placement collisions found. Yep, we're good on that. And then placement is within mapped bounds. Okay, so we know exactly why it was allowed to place. And then if I press here, then we get a fail based on, we expected there not to be collision, but there was collision. And then we tried to place outside the valid map area, because right here, the top tiles are outside of anywhere on the tile map which has tile data. But the bottom tiles are in conflict with the wall, because those have a layer 1 collision. So those are your basic rule indicator checks against the tile map and collisions. And just so you can see, if I go to the level for the tile map, if you actually want there to be wall collisions like that, you need to create a physics layer on your tile map. So you can see collision layer 1 here means that we'll get collisions on layer 1. And then when you're setting up your tile set, if we go to paint, property, physics layer 0, you can see the tiles which have that physics layer. So these wall tiles cause collisions at layer 1. And that's the basic idea of how you set up collisions with your tile map. Of course, you can customize the shape. They don't all have to be perfect squares. You can move the points like this and such. So last thing for this tutorial, let's show the spend materials rule generic. So you'll have an inventory that has materials. You want to spend those materials to place an object into the game scene. So for that, you need to have a inventory class. In my downloads for the project, there is a default simple inventory you can use and expand upon if you want. So that's called grid building inventory. So for the versioning of this, whenever I update the grid building inventory and I release a version of grid building, this is just going to be updated to the same version as grid building. Otherwise, the newest one for grid building should be compatible with the current grid building system. So let's open up this, and we're just going to bring in grid building inventory, just like with the base system. And then we'll enable that in project settings, and then plug in right here. The reason they're separate is because the grid building system isn't really meant to be a full inventory for your game. There's many different ways to implement inventory, and I'm sure that as you progress in your game, you're going to need to set things up very differently than I would. So that's why it's a separate package. It's just meant to be kind of a demo tester inventory. Okay, so grid building inventory, what we're going to need to do is to add an item container onto our placer node. So our placer node is the camera 2D, so that's our God camera. And so let's right click here, add a child node, and I'm going to be looking for item container. Okay, and this item container will have a number of slots, maximum stacks for these slots, so we can have 10 item spaces currently. And I'm going to want to create a new stack inside of the container. So we're going to start the game with resources to spend. So let's do a new base item stack. And then I'll click here and we'll create a new base item. The details aren't relevant. I could just call this gold if I want. So now we're going to be spending gold. Stack maximum, let's just say 10,000. And we have the count of 100. So our stack has 100 gold to spend when we load the game. And for this base item resource, I'm going to want to once again save that to the project so I can reference that in our other scripts like the placement rules. So let's right click here and save, and we'll go up to the root project, and maybe I create a folder in, let's just say the root, and I'll call this materials. And the material is going to be called gold material. Material as in it's being spent in order to build the building. Okay, so that we have that, we can easily reference it in our other script. Okay, so we want to reference the rule in our placeable. So the clothing mannequin's placeable. If we go over here to placement rules, we'll add one in here. We'll do spend materials rule generic. You also see that there's a spend materials rule that's included in the inventory plugin that just uses non-generic resources. So I'll show the generic version, and you can see why it kind of sucks to have to use generic resources, in the sense that we create a resource stack here, and inside that resource stack, we're going to need to reference a resource. But if you click here, you'll see that we have access to every single resource inside of Godot. And that just makes it a very unmanageable menu. And then down here, you can see the resource classes that are specific to the grid building system. But the easier way to assign it if you are using generic resources is just to grab the resource straight from the project. If you search material, gold material, we just drop that in here. So what we are putting here is resource stacks to spend. How many of each resource we expect to spend in order to place it into the game scene. I'm going to put 20 for gold material. Okay, the last thing we need to do is to tell the rule how to locate our inventory, because since this is a generic version, we don't know what our inventory class is, and we don't know where it is. So we need a locator. So I'm going to click down here, new node locator. And we have a few options here on how we want to locate. You can do it by node name, which makes sense if you always intend to call it the same node on any object that's going to be placing objects in the game. Okay, so we need to go down here to locator, so we can tell the rule how to locate our item container inventory. So I'm going to click here, new node locator, and we need to choose a method for how we're going to find the node. So you can use node name. And how this is going to work is it's going to grab our placer node, and then it's going to look in it and any nodes under it, and it's going to find the node that has this name. So we would want to call it item container, and it will find the first node called item container. You can also use script name with extension. So here the script name is itemcontainer.gd. So the first script that has that name, or is in group. So if you want to assign these nodes to a specific group, like an inventory group, you can search by that group name instead. So let's just try node name, and I'm going to do item container. So we're going to look for the node called item container, and that's going to be used as our item container / inventory for spending the resources. So it's going to check if there's the resources to spend, and when the building is done, it's going to actually spend those resources. Now, creating a locator for every single spend materials rule you place into your game probably gets a little tedious, because if you have a bunch of placeable objects, they're all going to have different sets of stacks to spend. So you're going to keep creating new versions of this rule. But you might use the same node locator. Like in all your cases, the inventory is still called item container, or still called inventory. So if you just want to reuse these settings every time, you can just save the resource. So let's go back out to the main project, and we could just create another folder here for resources or something. And inside of there, I'm just going to call it item container locator.trs. Okay. And now this is a saved resource, and you can keep reusing it over and over again if you need to. And let's go ahead and hit play and see if we set up the rule correctly. So I'm going to hit play, and let's hit B. We're going to grab the clothing mannequins, and I'll try placing it into here. So I'll spend material resources, requirements met. If I press out here, we fail because of valid map area. So we had 100 gold. We spend 20 each time. So we should be able to place 4 more of these mannequins, 3 and then 4. And now the 5th one, not enough materials, 20. Now it doesn't show what the resource is called. And I think that's just because we didn't give it a name. So if we look for gold, material, we have the display name, but maybe not the resource name. So resource name gold. Let's hit play. And we should be able to get that message there. So 1, 2, 3, 4, 5, and then 6. Not enough materials, gold 20. Now, it was actually supposed to use the display name if a display name was set. So I will fix that minor bug for a future update. But aside from that, seems like pretty much everything is good to go here. So steps you might go from here. If you're going to be having an inventory in your game for spending resources, you might want to create a little UI in order to show what items are in that inventory up here, so you know what you're actually trying to spend. But, you know, that's going way beyond this into inventory management. But hopefully you guys enjoyed this tutorial showing how to use the grid building system. I think since 3.1, it's a lot more straightforward, especially in creating the tile check rules. You don't have to have multiple indicator templates for each rule anymore. You just need to set which mask each rule is using. But one last thing I want to show you guys, in building system, if you do want to customize the textures that are showing for each rule that fails, let's try going into within tile map bounds rule, then there's visual fail settings down here. So you can change which texture is going to show if this rule fails specifically. Now, in the case that multiple rules fail, the one with the highest visual priority is going to show. So I could give this like a priority of 1, and then the collisions check rule can have a priority of 2. And that means that the collisions check texture is going to show instead of the within tile map bounds rule texture if these are both set and they both fail at the same time. But if there's no visual fail settings, it's not going to actually use this priority. So let's add a new indicative visual settings, and you can just assign a texture here. So I'm going to quick load, and I have some orange textures that we can use. So orange collision tile overlay, and I'll grab that in there. Oh, actually, I wanted the one with the B in the middle. And you can also change the modulate color if you want to modify this a little bit by, basically it multiplies this color by whatever the pixels you have in there. But let's hit play, and we'll see this in action. So I will try placing the mannequin. And if we go up here to where the tile indicators fail because of the tile check rule, then we get that third texture. So down here is using the defaults, but up here it has the override of the fail texture. So that's just one way that it just makes a lot more sense now. So you don't have multiple templates, it just has a texture replace function. So that pretty much covers it for everything that's new in the build system. So I do have another tutorial that shows setting up the rotation and flip actions. That was from a previous update. And if you want to have multi-build by dragging, you can just toggle that on, hit play, and we'll try placing these clothing mannequins. So I'm just going to press once with left mouse button and drag this, and it keeps placing until it runs out of materials, or basically it only places when it's actually valid. So you can see that it didn't place above the mirror or this area right here. So that is going to wrap up this tutorial. I hope you guys enjoyed it. So it's available on itch.io, Ko-Fi, and Patreon as well. Thanks for watching to the end. Thanks for everybody who's supporting my channel so that I can continue to make these plugins and tutorials. And I will see you guys in my future video content.